in this hands-on, we will be talking about working with satellite swath imaging. Can you see my PPT? Can you see my PowerPoint slide?
Yes.
Yes.
Okay. So here we will briefly see the brief overview of satellite data levels, the data that we have available. We'll also, I prepared 2 notebooks. The first one is for you to get some idea about what flag information contained in level 2 data means and how you can look at it and what kind of information it gives you. And we also, and another notebook, actually, the order of the notebook is there's a mistake, a reverse, should be 2 and 3 there, but it's flipped. So we'll see about a quick example of satellite data validation. So the data, as it is obtained, we have what is called level 0 data, which is uncalibrated science data. This is available in what is called engineering unit in raw format. For example, NASA or JAXA or other space agency, they collect the data in this raw format, which they call level 0. And then they process it to level 1A. This is, again, uncalibrated science data in archive format. So this is the format that the data is kept after it's collected. So for this data, they have added information like geolocation, for example. And we also have what is called level 1B. This now is calibrated data. So for this data, instrument or radiometric calibration, so it means coefficients about the response of the sensor and other things have been applied so that now this become calibrated, and also because previously we have georeferenced data, so now it's calibrated and geolocated science data. And then we have what we call level 2. So maybe people who are familiar with ocean color data, maybe this is the data mostly used. Level 2, which is still is derived geophysical science product. So here then we have applied algorithm that convert the signal, satellite signal, into a geophysical product like chlorophyll data. And this data is still is geolocated but not projected, so it means it's in the satellite view projection. So it might be distorted depending on the images. And this is the data that we usually use for example, when we compare in situ and satellite data. So this data is in satellite native resolution, meaning if the satellite is designed to be 1 kilometer resolution, so this is the one that will keep, still keeps that native resolution. And later we have other products like level 3, which are, then this is kind of from level 2, we aggregate data temporally or spatially, and then we derive new product. Usually this level 3 product is mapped, means is on a radar grid, not on this satellite view, which might be products, data, and mostly distributed in many websites. And we also have what is called level 4, which can be output or result from analysis of data, for example, chlorophyll, like from IOC product. It's a combination of one algorithm and
Sorry, there is a technical problem. Let's hope that he will be coming back soon.
Oh, sorry. I think there were some issues with internet. I don't know what happened. So I will resume my presentation. So I was explaining about different data product. I'm not sure where exactly it stopped suddenly. Yeah, I was reconnected. I lost connection. But I was explaining about different data levels, like level 2, which is the mostly used by the ocean color community. And we also have a level 3, which are coming from level 2, but by combining different level 2 product temporarily or specially to generate composite, also generate global maps, for example, like the primary production map we saw earlier. And we also have level 4, which is can be model output or result from analysis of lower level data. So like, for example, YOC product. And this is kind of a brief overview of the advantages of and disadvantages of level 2 product. So level 2 is unmapped data in native satellite swath coordinate system. So it maintains the spatial resolution and geometry. So pixel might not be nicely set on the map, but it keeps the native resolution. Includes in a single file many geophysical parameters for the case, for example, like NASA or JAXA product. And satellite in situ validation exercise are mostly performed in this L2. But disadvantage is that it can be distorted map, and data must be we must apply data screening to remove low quality data prior to use, and includes large files. So these files are very large. Sometimes we only want to retrieve chlorophyll data, but the files have chlorophyll and RRS, so yeah, end up taking up space, a lot of space, and it requires more technical expertise to work with. And in terms of understanding what the quality flag information is, here I show you some example, for example, of ocean color level 2 data from NASA and from JAXA STLI. So for example, the GOSI data, which is the Korean geostationary satellite, ocean color satellite, is also available on NASA website. So the flag information is similar to this for almost all data provided from NASA. They keep consistent, the flag information. And NASA here we have 32-bit flag, and on the JAXA we have 16. So you can see, for example, these images are taken from the online matchup tool, and I will be demonstrating this also. And here you can see, for example, here we select atmospheric failure. Sometimes there is issue with the atmospheric algorithm or other things, or the data is on land, or the data is under the cloud or ice, and or there is a stray light issues, all other things. So we will be exploring this. You will have the chance to select one by one and see what changes practically, and get a sense what this flag information is doing. And this screen is coming, I mean, like I say, this image is coming from our recently developed online matchup tool. And this online matchup tool basically is doing this exercise of aggregating, combining the data we collect in the field using ships or other instruments with the data collected by satellite instruments. So this tool will do the work for you. You only need to submit your field data, and then it will search based on the time and location you collect the data. It will find satellite images and do the matchup for you based on a criteria you define. So this online matchup tool is available from this link, and it includes mainly two parts, very simple. The first one is this selection criteria. So here you will select the instrument you want to do the matchup with your institute data, and you can also indicate whether you want to do for ocean color or inherent optical properties and other things. So based on the instrument, there are options that might not be available here for you. And you can also indicate inside the ocean color product, what are the parameters you want to do the matchup. I'm sorry, my internet is unstable for some reason. I don't know what's wrong. I'm very sorry for inconvenience. Yeah, I was seeing, and then we also have here on the right side, we have list of institute data points. Here we'll select the list you prepare with your field data, and this list is in CSV, comma separated value. And here, this is a link to a sample file. You can see it's also inside the materials, so you can find it. And this file should contain the geolocation, longitude, latitude, date, and time. And also, for example, I'm doing chlorophyll. I have here chlorophyll data. If I'm doing for RRS, I will have the RRS band. And the time should be UTC. And we also have contact information. So you will submit this matchup request, and you will put your name and the email. It doesn't need to. You can put your nickname if you don't like to put the name. But it should be real email, because the tool will be running. Sometimes if the data is a lot, it will run for more than an hour. So you don't want to wait there and just see a blank screen. You can just push submit and do other things while the process is running. And once it's done, an email will be sent to you with the link to download the data. And the next one is validation criteria. So this validation criteria is where you select, for example, pixel window. Here, you have your point, your field point, for example, on the right side top, you can see there is a box here with squares with yellow in the center. So for example, the yellow is your field sample and it's located here. So you can choose around this field sample how many pixels you want to look at. If you say, for example, here we say 5 by 5, so it means you will have 2 on top, 2 below, left, right, and then it will make this square, and then you get 25 pixels. So, and then this will be looked at. And then after that, you can also specify. So this number you specify here needs to be an odd number. It can be 1, just the point. It can be 3, or it can be 5, 7, and so on. And then you can specify how many within this search window, how many have to be valid, means how many have to have data. So for example, if you have 25 and you say, I want 50% to be valid, it's approximately 13 pixels. So if 13 valid, then this becomes successful matchup. If this condition is not observed, then it will just skip. And you can also specify the time, the maximum time difference between your observation, in-situ observation, and your satellite, and the satellite image to search. So this one, it will center the time on your point and then search 3 hours before and 3 hours after. And then anything that falls within this window, it will select as a match and then would be used for the matchup. And in the case of SST, you can choose the quality of the SST. Here, 1 means, 0 for this SST quality, 0 means best quality, and 4 means worse. So you can choose within this window which SST data you want to use. You can also select the pixels. You can use, select the flags you want to apply. And again, we will do a simple exercise to see the different effect of these flags. You can select what kind of flags you want to apply for the screening of the data. So once these flags are applied, it means any pixel that is within, for example, falls in where there is a land or there is a cloud, it will be eliminated. And then you just get good quality data. And then once you do all this selection, you hit submit. And then if you hit submit, this will show the progress here. It will indicate that the process is running. And at that point, you just need to be doing other things and just wait for the results to be sent. And once it's finished, you will get a text file that looks like this. It will indicate, for example, here I selected Modis Aqua, and this is the time when the matchup was generated, and my username, contact email was sent to this email. It will tell you about missing info, what number indicates missing information, and what is the delimiter used, and how many lines contain header information. So here is 14. And then the validation you selected, the condition that you indicated in the matchup. So I selected the POX 555, and I said the minimum valid should be 25. And I said time difference is 3, and these are the level 2 flags I selected for the screening. And then from 15, then I have the header and the data. So, the header of the data. So here you see cruise, year, month, day, and so on. And more to the right, you get other information about the satellite file name, satellite images, and the pixel values, level 2 flags, and so on. Yeah. So these 2 links you can access, for example, if you have access to Earth Engine, you can try using this G that demonstrate. This is more kind of more flexible and easy to use. You can select, you can access the Earth Engine, which demonstrate the level 2 flag information, how you can look at the level 2 flag. If you don't have that, we will be opening the Jupyter Notebook. I will start with this Jupyter Notebook, as everyone now installed the Jupyter Notebook.